greatest mathematicians, greatest legends of all times. Here we are on differential calculus again. Question 25. 25.1. They ask us to find the derivative using first principles if f of x is equals to 2 over x. This is how we go about answering the question. This is how we go about answering the question. Okay, question 25.1. Question 25.1. So we are given f of x is equals to 2 over x. So the first principle formulas is given by f prime of x is equals to the limit as h tends to 0 of f of x plus h minus f of x and then all divided by h. So I'm going to explicitly compute f of x plus h. So f of x plus h will give me it will give me 2 over x plus h. Then I'm going to substitute into my first principles formula. So f prime of x is the limit as h tends to 0 of 2 over x plus h, then minus f of x will be 2 over x. And then all of this will be divided by what? By h over 1. Then we continue. The limit as h tends to 0. So here in the bracket here, we are subtracting fractions with different denominators. So the LCD is going to be x times x plus h. I'll cross multiply. I'll get 2x. I'll get negative 2 times x plus h. And then divided by the product of the denominators, which will be x and then x plus h. All of this will still be divided by h over 1. So I'm going to quickly simplify within the square brackets. H as tends to 0. Then if I clean up inside the bracket here, I'm going to get 2x minus 2x minus 2h. And then all of that divided by x and then x plus h. Then now we are going to tip and times. It becomes multiplied by 1 over h. Still have our limit as h tends to 0. Then inside the bracket there will be left with negative 2h. Then we multiply the denominator separately. We get xh or hx times x plus h. Still have our limit as h tends to 0. And then the h will divide the h in the denominator. We have negative 2 divided by x squared plus xh after we distribute the x into the bracket in the denominator. So we're still continuing. Then now we are going to perform direct substitution since now the value of h equals to 0. It's in the domain of this expression. We will get negative 2 over x squared and then plus x multiplied by 0. And then this will give us negative 2 over x squared. So this is the value of the derivative. Remember, the derivative is interpreted as what? As the gradient of a tangent line at the point in this instance. Right, we move right along to the next question. Okay, the next question says 25.2.1. 25.2.1. We are given the function h of x is equals to 2x cubed and then minus 4 over x and then plus 3 square root of x. So we are asked to find the derivative. So we are going to apply the rules here. We could apply first principles, but it will be very difficult to do. Not impossible, but difficult. So we are going to use rules. I'm going to use the power rule. So before I can apply the power rule, I am directly going to simplify and get this given function into the prescribed form of a power function. So this will give me negative 4 x to the power of negative 1. This is a 1 here. The exponent will become negative when I use the exponential laws. Right, then this will become plus 3 x to the power of 1/2. I'm applying Set's laws. I must remove this h prime here. Sorry, I made a mistake. I haven't differentiated yet. I was still preparing the function. So then I can put h prime in the next step. H prime, now I'm differentiating. This will give me 6x squared, and then plus 4x to the power of negative 2, and then plus 3 halves x to the power of negative half. Then I can continue with the problem and get all exponents in with positive signs. So this will give me 6x squared, then plus 4 over x squared, and then plus 3 over 2 x to the power of half. I can still express the derivative of h in set form. I get 6x squared plus 4 over x squared, then plus 3 over 2, and then square root of x. So this is our derivative of h. This is the derivative of h. This is the answer to the question. The derivative of h. That's the derivative of h. Then we are going to look at the next question, 25.2.2. 25.2.2. So 25.2.2, 25.2.2, we are given d sub x. Let me just quickly check here. 8x cubed minus, okay, it's 8x cubed minus 27 all divided by 2x minus 3. I think that's what we have there. Let's double check. 8x cubed minus 27 over 2x minus 3. So I'm not going to apply the quotient rule here. Remember, this is high school. So I'll continue with the power rule. I'll first get this into the required form. You can factorize this using your long division or synthetic division, but I'll rather factorize this one using grade 10 mathematics. This will be 2x all to the power of 3 minus 3 to the power of 3, and then divide this by what? By 2x minus 3. I can put that in brackets like that. 2x minus 3 in brackets like that. So then I can see that in the numerator, I have difference of 2 cubes. Then I will factorize it as open a bracket for a binomial and a bracket for a quadratic, then divided by what? Divided by 2x minus 3, like that. So the cube root of 8 is going to give me 2. The cube root of x cubed will give me x. The cube root of 27 will give me 3. I put a minus. I'm going to square this one. It gives me 4x squared. I'm going to multiply and change the sign. So that give me plus 6x. Then I'm going to square negative 3. I get plus 9. And then this one will divide out with that one. Still have my dx because I was still preparing the given expression. 4x squared plus 6x plus 9. Then I'll apply the power rule now. This will give me 8x plus 6. So therefore, this means d sub x of 8x cubed minus 27 divided by 2x minus 3 will be equals to 8x plus 6. So that's the derivative. 8x plus 6. That's the derivative. That's the derivative there. 25.2.2, we are done. Then we are going to look at the next question. So I'm going to do this next question here on the space here. I'm going to answer here. I'll answer that one here in red. In red for danger. Right. They say explain by doing the necessary calculations why the tangent to the curve of f of x is equals to minus x cubed minus 2x will never have a positive gradient. So we need to show here that the derivative of this function will forever be negative for each values of x. So let's go and find the derivative of this. So f prime of x will give us negative 3x squared minus 2. Therefore, I can factorize. This can be expressed as f prime of x is equals to negative. If I take out the negative there, then I'll be left with 3x squared plus 2. So then we know that this function inside the bracket here, this one, I can draw this quadratic function. This is how the quadratic the quadratic function look like? Let's say let g of x to be equals to 3x squared plus 2. This quadratic function has a turning point and y-intercept at 0 and 2. So this is how this function is going to look like. That's how the function is going to look like. This here is 2 here. I'll say the point there is 0 and 2. That's your y-intercept. This is your x, and this is y. So graphically, you can see that for each and every value of x in the domain of this quadratic function, the graph will never be below the x-axis. So that tells you that the tangents will always be having positive gradients. This is the graphical interpretation. So let's continue now and explain the algebraic method. So x squared will be greater than or equals to 0 for all x elements of real number. So each and every x value that you substitute here, you are always going to get a positive number. And then 3 times x squared will always be bigger than or equals to 0 because you're multiplying a positive quantity by a positive number. You get a positive number. And then if you add 2 positive numbers, you're still going to get what? Positive. And therefore, you're going to conclude that the tangents will always have positive gradients. Positive gradients. Since the gradient function, this is called the gradient function or the gradient of a tangent under the point. Since the gradient function is positive for x elements of real numbers. That's how we do it, mathematicians. That's how we do it. This was just a warm-up. This was just the morning breakfast for the brain. Thank you, mathematicians. See you again next time.